In lesson 6.6a, we're going to be looking at solving exponential equations. So that is going to be equations where you have an exponent on one or even both sides of the equal sign. So looking at the first key concept, if you have b to the x power is equal to b to the y power, that can happen if and only if x and y are equal. So you have a base to an exponent is equal to a base to an exponent. That can only happen if the bases and the exponents are equal. So an example of that would be 2 to the third equals 2 to the x. Right? Notice I have my bases of 2. That means that the exponents then also have to be equal. So that's just a quick example of the kind of questions we're going to be looking at today. So in our example here, I have 3x equals 9 to the fourth. So I could evaluate 9 to the fourth on the right side of my equation and then try to solve for x. The other thing I can do is to rewrite 9. Right? I have to have bases that are the same. So I know that 9 is equal to 3 squared. So that allows me then to sub in on the right side of my equation. So I can sub this in here. I can sub 3 squared in for 9. And since I now have bases that are the same of 3, I can drop the exponent parts down. X equals 2 times 4. Right? We have power of a power says I'm going to multiply these exponents right here. So then it would simplify out to x equals 8. And to check that, I could quickly enter those into my calculator and look to see if they are indeed equal. So I can throw 9 to the fourth power into the calculator. All right, that was my right side of my equation, 6,561. And then I can sub that 8 in, 3 to the 8 power, and they should equal the same thing, which they do, 6,561. For example 2 here, 2 to the 5x equals 4 to the 2x minus 1. I can sub in something for 4. I know 4 is equal to 2 squared. I need a base of 2 because I have a base of 2 on the left side. 2 to the 5x equals 4, which I can replace with 2 squared, to the 2x minus 1. I can then drop down the 5x equals 2 times 2x minus 1. Now it is important to put parentheses around the original exponent right here because we need to be sure to distribute everything out correctly. Common mistake is to not distribute all of this out. So 5x on this side is equal to 4x minus 2. And so if I subtract the 4x over, I get x equals negative 2. Right? And then I can sub that into the calculator as well. 2 to the 5 times negative 2, so 2 to the negative 10 power. And 4 to the 2 times negative 2 minus 1 power. And I see that they are indeed equal. So that is what we are going to be working on with solving exponential equations. There are some circumstances where you would need to change both sides of the equation to a common base. So you may need to change both sides into something so that you do have a common base. The last thing, compound interest, I wanted to review again. P for principal times 1 plus your interest rate as a decimal divided by n to the n times t power. So here is an example of that. I have an investment account that pays 0.54% annual interest compounded quarterly. We put $4,000 in the account. They want to know the balance after 8 years. So again, I have A equals my principal, which is 4,000, times 1 plus my interest rate as a decimal, so 0.054, divided by the n value, which is how many times it is compounded in a year. So quarterly means 4. And then my exponent is the 4 again times how many years. At this point, it becomes a calculator problem. We are going to start with the decimal part, right? That fraction, the 0.5054 for the interest rate divided by 4. And then we're just going to keep going inside the parentheses there. We're going to add the 1. And then we can take that value to the 4 times 8 or 32nd power. And then that is what gets multiplied by your principal, 4,000. So after the time, you get an amount of $6,143, and we'll round that up to 56 cents. Okay, so there you go. That is your lesson on solving exponential equations.